Thank you very much for receiving me here. I'm going to talk about how I started working with AI by using D-Lang. It began just as a play, and I did not imagine that I would end up as a speaker at DConf. Because it started as something that I was doing just because I was bored, and in the end, it grew to some extent to which that now there are some people who have been contacting me who are interested in the work I'm doing. Concerning AI, AI is something that when I imagined it, I thought about, those robots, those things that you see, like computers that take over the world and things like that, androids, very smart machines. I imagined it would be something like that, so I thought, my God, it must be so difficult. I'm going to have to study so hard. And later, as I started really getting into it, I realized it wasn't really that difficult, because it turns out what currently people call AI, artificial intelligence, is actually very far away from any form of intelligence. I'm not sure if you people have already seen this over here, or this one over here. So, I've discovered that what they call neural networks, machine learning, things like that, is just an application of the fields of statistics and probability. It just applied math. It doesn't really involve real intelligence. It doesn't really create an actual brain. It simply creates a system in which a certain path becomes more likely to be followed, whereas the other paths become less likely to be chosen. And therefore, if the test data is compatible with those paths, it will give you the correct result. And I have seen, more often than not, AIs that turned out to be nothing more than a bunch of if-else. I saw once a guy speaking. He was talking about a chatterbot, right? An AI that talks to you, and he said it is able to reply very fast. And the reason why it replies so fast is because if you look at the source code, it's just a gigantic list of if-else, if-else, if-else. So it goes through very fast. When I started studying it, I found this quote on the internet, which I found interesting. I did not understand what it meant back then. But nowadays, I get very well the point, because right now we're in the year of 2023. We have things like ChatGPT, right? And guess what human beings with their incredible creativity have been using AI for? I'm going to click here on a video. Oh, unfortunately, people cannot hear it, but it's okay. I think people can see here in the video. It's a scene from the film No Country for Old Men, and they managed to put the face of Arnold Schwarzenegger. If it had the audio, it would be way funnier. I keep imagining if people like Isaac Asimov, if we could bring them back to life and show them what we have been doing with AI, I imagine what their reaction would be.
I said, what time do you go to bed?
Oh,
which button?
Somewhere around 9:30. I'd say around 9:30.
I could come back then.
Why would you be coming back? We'll be closed.
Yeah, you said that.
Well, I got to close now.
You live in that house at back?
Yes, I do.
You lived here all your life?
This is my wife's father's place originally.
You married into it?
We lived in Temple, Texas for many years. Raised a family there. temple. We come out here about 4 years ago.
You married into it.
That's
Okay, that was quite funny. Now let's go back here to what we were actually working on. So I searched for it and I was unable to find the tools to work with AI. It is not like in Python. In Python, you have so many tools. You have PyTorch, and you have also tools to work with data science, right? You have NumPy, you have Pandas, you have so many packages. I searched the package repository of dlang. I found this package over here, but I'm not sure exactly how it works, and I don't know if it really be useful for what I have been doing. So I hope there are more people there who have been using D for AI. So far, I haven't met anybody. I hope I get to meet someone here. And I hope that soon there will be more tools available in our community for AI, which is a field that at the moment there is a big hype about it because they're using it for everything. So why is it that I use the dlang to do it? I could have used Python, right? But the thing is, it's part of my personality that I am kind of rigid. I like to do things the way I like to do things. I do not like to adapt to do things in ways that I find uncomfortable. So I did not want to learn frameworks like PyTorch, and I did not want to move to another language. I wanted to stick with the one that I liked. So I figured, well, if there are no libraries out there, I'm gonna make my own. So I decided to use aid from other libraries. I decided to stand on the shoulders of other people. I used the ARSD library. I had studied very deeply because I wanted to learn how to make a computer game in D. And for that, I needed to work with multimedia. I needed to work with sounds and images. So I studied this library to the extent that I was able to make a pretty large RPG game purely in D. And then I figured, well, I could create my own D AI library that works at least here on my personal computer. And I could use, if I wanted to give it a GUI, I can do it with this library here, and that's exactly what I did. My first experiments. When I started years ago, I think it was in the year of 2019, I first just made a simple agent that would find its way out of a maze with the A* algorithm. So I simply got an image from the internet. I Googled Pac-Man, and then I found an image of that little maze, and then I managed to divide it into squares, and I made this simple software in which you could pick the square in which the agent starts, and it would find the shortest path to get to the exit. Something quite simple, but I found it interesting because it was done purely in D. When I showed it to other people, they kept asking me, so what did you use? PyTorch? Did you use, they kept listing all of those popular frameworks, and I said, no, man, I didn't use anything at all. I did it all from scratch. And apparently they weren't able to understand that. No, it's serious because I said it 3 or 4 times and they continued to ask me which framework I had used. I made once a simple animation just to illustrate the, I don't know how to pronounce that. I hope it is Digikistra. Yeah. Dextra. Okay. Just in order to illustrate this algorithm in action. It is that simple algorithm to find the shortest path to get from one point to another on a map. So I made the software that you could place the points, the nodes, and then you could connect them to make the vertices. And then you could choose the one which was the start point, the one which was the end point, and then it would show the agent making the selection until it could calculate which was the shortest path. And later, I intuitively created an OCR, an optical character recognition software, inspired by the same idea used by Emmanuel Goldberg. Goldberg was a man who he created one of the earliest forms of OCR. I think it was in the early 1900s, which was a form of OCR based on light, based on the pixels, the white and the black pixels of a character in order to read microfilm, in order to be able to interpret the text of a microfilm. Microfilm is like a small slide that can be expanded into a big text. And I made this OCR, and it worked reasonably well. So here, that's what I was talking about, the module that I wrote. I need a framework to create neural networks because that's how it works. If you want to create a neural network, you have to create all of the neurons, all of the synapses. You have to create the learning algorithm. You have to create the backpropagation algorithm. You have to create the algorithm which is going to perform the activation using the sigmoid function, although there are others. And I figured that doing it all from scratch over and over was too time consuming. So I thought I'm gonna create a module that has all of that implemented. I just have to call it into my code. I just have to import it and use it all. And I made a module, indeed, a simple code with the name neural network that has the class neuron, the class synapse, and it has the function that the sigmoid function and the gradient function. And it has the main class, the flagship, is a class called network, which the network itself, which is going to draw on the neuron classes and the synapse classes. And then it is going to perform all the learning algorithm with the functions. And this class called the net, it is able to work by itself. It's very self-sufficient. So all you have to do is to give it the training data and let it think by itself. I use the classes instead of structs. I usually prefer structs, but I use the classes because classes go by reference. I needed all of the different neurons and synapses in the network. They had to be talking to each other all the time. They had to be exchanging information. So they had to be passed by reference instead of by value. And that's why I use the classes heavily instead of structs. Here. That's just a screenshot I took, the module neural network. It simply uses the ABS function of the math module from the standard library. Then it has the learning rate, the sigmoid function, the derivative. And I did not show the rest of the code, but here begins the class that represents a synapse. As you can see, my style of writing is super simple. I always try to stick to the simplest form of writing. I try to avoid making the code difficult to read. And I also I follow this rule, which to me is very important, the rule of always putting the first brace underneath and not in front. I find it very ugly when people put it in front. All right, then. Once I had finished this module, I figured, okay, now I have my own framework. But let's suppose that I'm making a big network, a network that has 5 layers, and each layer has 10 neurons, and there will be more than 100 synapses. I would have to be declaring them one by one. I would have to be typing there all of the neurons, then typing all of the synapses, and then reading it to make sure I didn't make any mistake. So I figure I'm going to find a way to automate that. I'm going to make a software that does the job for me. And that's what I did. Because when you're visualizing your work, when you're able to draw it, it makes it much easier for you to understand it and to check if you have made something wrong, instead of simply working with pure base, with pure text-based stuff, okay? Because when you're working with just the text, the chances of you having made a mistake are much higher, and then you can spend hours debugging it. So I made a software that you just draw the network with a mouse, connect it all, and press enter, and it creates it automatically. It's very, very easy to use. And I have been using it almost every day. Here, that's an example. You can see here there are 5 layers. I could add more later, but for now, the software only supports 5 layers. And then all you have to do is to right-click to create a neuron. It gives the name automatically. The neurons in the first layer start with A. The ones in the second start with B, and so on. And then all you have to do is to click on a neuron and then click on another one, and it already connects the 2 of them. And you can see each neuron has its own color. I decided to make it like this. Each neuron, upon creation, will receive a random color. That way you can visually trace back the synapse to see what belongs to who. So here, I know very well that the blue synapse belongs to A3. Over there, you can see that the green one belongs to C1. Some of them have colors that got a little similar because it is random, right? It could give very similar colors. But the idea is simply to make it easier for you to understand without getting confused. And here I placed the instructions, which did not appear here, but there is a list of instructions teaching the user exactly what they have to do. And now, okay. Later, I improved the OCR software I had made. I had to make my own training sets because it's like this. I searched the internet to see if I could find tens or hundreds of images of letters so I could fit into it. I found the MNIST repository, which is the most popular one. It has around 40,000 images, but when you download it, it is not in a format that you can see. It's not in bitmap or JPEG or PNG. It is purely in a mathematical format as a matrix. I wanted it to be in the raw image format. So I created my own training set using images. I would simply type them using several different fonts. I would use 25 different fonts for the letter A, 25 different fonts for the letter B. Then I would edit them using GIMP. And I later placed it on the internet so other people can download it. So it's something that I was very proud of because this repository I created, it is the only one of its kind. Like I wrote here, it turns out to be hard to find something similar because this OCR software I made, it works like that. You open it, you type the name of the file, and then it opens the file, and it scans the file in order to recognize all the digits. You are probably not going to find something so easy to use. There are some few OCR softwares available there, and they are usually paid. You have to pay for them, and they can be quite expensive. I did not yet make mine available for people to download it because I am still finishing some details, but later I'll make it available and then it will be free to use. And it is 100% made in D. This is just an example here. I open this file and then the OCR software scans it to find all the lines, then it finds the frames of each and every letter. You can see here each letter has a green frame around it. And once it has found the frame of each and every letter, it goes through each one of them, scanning them, and then it shows an output string telling you which characters are written here. Oh, the color classifier, that was my second project. I had an idea. What if I make a neural network that I show it a color and it tells me the name of the color? Like, I show it the color of this background and it says, that is purple. Or, well, depending on your point of view, you could state it is pink, but well, anyway. I thought it would be easy to make, but it turned out to be much harder than I thought, which may help explain why I didn't find anything similar out there. I do not think there is any software that you can simply download that does this kind of classification so easily. I had to ask friends for help to classify the colors because I know nothing about colors, about the theory of colors. My software uses the RGB values, the red, green, blue values of the pixel. So it is a neural network that analyzes all of the relations between the RGB values in order to tell what is the name of that color. I had to iterate many times, refactor the code many times, and try many different architectures until it finally worked. Here, that's an example. Here, it managed to understand it was pink, it understood it was purple, it understood it was red, and it understood it was violet. It works like that. You give it a color, and it tells you the name of the color. It still confuses a few colors. I still have to improve some details because there are certain colors that even people could confuse, even people, depending on the shade of red, people could wonder if it is a red or a pink. Here, this is one of the early networks I made to classify the colors. The input neurons are the relations between the RGB, the value of the R, the G, the B, then the difference between the R and the G, the difference between the G and the B, the difference between the R and the B, the sum of all three, all relations I could find. This was one of the first attempts I made. The network creator, it still did not have the random colors. It was all green. I figured that my networks were getting big. Training them was taking hours, sometimes more than a day. I have a simple old computer with an AFX 4300 CPU. It only has 4 cores. Try to use it while it is training a network and it becomes super slow. So I did not want to spend money buying another computer, so what I did was simple. I talked to people who were throwing computers in the garbage. I say, give it to me instead. I simply restored them, even painted them to make them look cool, and then I set them up so they spend the whole day there thinking. They sometimes spend more than a week running 24 hours doing the training of the networks. I have 2 of them, one with a quad 2 core and with a core 2 quad and another one with a core 2 dual CPU. So they are very old, like 15 years old here. This one here is my main computer, the one I use, and these 2 here, they are the trash computers that I have converted into thinking computers. I spend the whole day there doing the thinking. You can even see here the details because of the way I painted them. You can see. I still want to show you guys an example, so I'm gonna speed up a little bit. My advice to people who want to learn AI, you're gonna need to use a math. Knowing high school math will help a lot. You're gonna need to know some linear algebra and some calculus. You're gonna have to work with matrices and dot products, which is linear algebra, and you're gonna have to work with derivatives of cost functions, which is calculus. It is something that you are gonna take long, because it is hard. It took me a long time until I finally understood it. You're gonna read it the first time and you'll not understand it. Then you read it for the second time and you start to understand it. You read it for the third time and you have an idea. You read it for the 4th time and you begin to truly understand it, and then when you read it for the 5th time, then you finally understand it, and then when you try to implement it yourself, then you discover that you did not understand anything, and then eventually you finally get there. Oh, and try to get an intuitive understanding before going to the math. Try to understand, try to visualize how it works, and then you try to know all of the equations behind it. I'll show you people an example here. Here, I have written 2 networks, one called the linear and one called the nonlinear. Here is the network creator, and here is the DMD GUI. I find the prompt something so primitive that I decided to make a GUI to use DMD. It's actually something quite simple. It simply uses the ARSD library to make this image, and then it sends all the commands to the operating system later. It's just a wrapper, something quite simple. But here I can type the name, and then I choose the flags, and then I click on compile. There, and then I just oh, it has RDMD too. If you wanted to just compile it and run it immediately, you can use it here. But for our case, this one is not going to work because it is using an external library. And then all you have to do is to press enter to run. There. But I have to show you people exactly how these networks were built here. Let's think of a scenario in which I have 4 numbers. 2 of them will tell if the result is true or false. Only 2 of them matter. Like this. So, it's like this. There are 4 numbers. 1, 2, 3, 4. Only these 2 matter. The other ones don't matter. Only these 2 here. If either of them is 1, the result must be true. If either of these 2 is a 1, the result will always be true. The result will only be false if both of them are 0. So here, I call it linear network because this is something that in math they call a linear relationship. The things that they are related to each other in a linear manner. So here, I'm going to open the network creator. And there it is. So here, 4 input neurons. Everything you're seeing here, all softwares I'm using, they were written 100% in D. So these are the 4 neurons. And it will have 1 output neuron, only 2 layers. 4 layers is the minimum, so it becomes deep learning. So if I went all the way to the 4th, it becomes deep learning. But I do not need deep learning for something so simple. So here, I'm going to delete this guy and delete this guy. Now I'm going to connect to these guys here. There. Oh, by the way, there is the focus mode as well. If I wanted to focus on a neuron, I just have to right-click it. And then, no, this was this one here, there. It shows everything that is directly connected to it. So like here, for example. If I focus on neuron C1, it shows me everything that is directly connected to it. If I focus on C2, it shows me everything that is connected to it. It is a way for you to be able to trace back all the path of the neuron if you are making a very large network and you are beginning to get lost. Once you select, you can also delete all of the forward synapses by hitting Control here. And if you hit Escape, you will erase the entire network. Now for our example here, let's just create a simple network that is going to understand that only those two values matter. Here, I've clicked it, and now I just press Enter, and voila, it's right here, network source code. There it is. It already creates all the source code for me. There it is. The neurons, the synapses, the forward synapses, the layers, the network, the learning rate. It's all there. It even gives me a list with all the weights in case I want to store the weights later, right? You often want to save all the weights in a text file so you can reuse it later. But here we're not going to need it. I just have to copy it and paste it inside the file where I am going to use it here. Here. I'm going to delete this one and put the new one. There. Yeah, perfect. Here, that's the training set. And these are the answers, right? The answers to each one of them. I know it may be getting boring for some of you people, but it will get amusing very fast. As you can see, just each one of them is just an array with numbers. If either the first or the third is a 1, the answer will have to be a 1, 2. If both are 0, the answer will be a 0. Here you have all the network created. And now you just have to train it here. Now we train it many times. You can see the simplicity in my code, right? You can see how I use very basic features, right? Nothing fancy. No at safe, no at property, nothing difficult, no scope guards, nothing. It's very, very simple, very basic. Now I just have to get each example of the training set. I have to adjust the learning rate. Can you people notice that I have 16 answers, but 12 of them are 1s and only 4 of them are 0s? Which means it will be increasing the values of the synapses way more often than it will be decreasing them. It will be considering to be true 3 times more often than it will be considering to be false. So in order to deal with this problem in a simple manner, I simply decided to adjust the learning rate. When it is the learning rate for the wrong cases, they will be 3 times bigger than the learning rate for the correct cases. I simply do the ratio between how many right cases, how many wrong cases, and the learning rate will be proportional to each of them. And I just have to make the network think, net.think. That's all. Net.think, and it gives me the result. That's all it does. And then I get the error. And if the error is significant, it learns. I decided to tell it to only learn when the error is noticeable to prevent overfitting. So only if the error was 5% or more, then it learns. So it's just net.think and net.learn. These are the 2 member functions we're going to call. Quite simple. And then you just check if you worked here. You just test. Here, it's simply going to show you all the results after the training to see if it worked. So we train it 200,000 times, and then we check it. Quite simple. Let's see if it worked. Oops, this time it didn't work. I think I know the reason why. It's because it was not supposed to have this here. This was not supposed to be here. It still doesn't work. Huh? Of course, I forgot to save it. I was so focused on that, I didn't even save it. Yeah, it worked. Let's test it, and voila. Here, it got all the first 12 close to 1, and all the last 4 close to 0. The first 12 were supposed to be true, the last 4 were supposed to be false. This guy here got in the middle. It's because this case here was a special case in which all the inputs were 0. Here, it was a 0, 0, 0. If all inputs were 0, that means there will be no activation. And as a result, when it goes into the sigmoid function, it gives you just 0.5. So it's kind of like if everything is 0, the network doesn't know what it is, it chooses in the middle. Now, let's try it with something more complex. Here. This is a non-linear network. Now it is different. Now, I have a problem in which okay, here it is only gonna be true when one of these guys is 1 and the other one is 0, like an exclusive OR operator. So it is only true if these two are different. If they are equal, if they are both 1, it will be false. If they are both 0, it will be false. But if it is 1, 0 or 0, 1, it will be true. Let me close this. Hold on. Here, that's the non-linear network. It's the same thing, but the answers are different because the answers had to be changed, so it will be equivalent to what I just said. Now, let's create this network. If I create this network like this, it won't work because the network was too simple in order to be able to understand this problem, which is more complex. So here, I just have to go down here. Here. I'll put it here. Now, save it. Now it is non-linear network. Non-linear network. There. And it gets everything messed up. You see, it's a mess. So I'm going to have to make this network smarter. Think of a rat. By adding more neurons and synapses to his brain, he will become smarter. So that's what I'm going to do here. I'm going to add more neurons here. I'm going to add here. I'm going to add several of them. So I'm going to, you have to think about the associations you're making. I'm going to use one neuron that associates everybody, one that associates only the first 2, one that associates only the first 3, one that associates only the second 2, one that associates these, one that is going to associate these 2, one that is going to associate these, no, not this one. 2, 3, there. here. And these two will be associated here. And now, there. Okay, generated it, network source code. A brand new source code, much bigger than the previous one. Now I just copy it and paste it. Here. Put it right here. This place. There it is. Now I can. Okay, let me close it. Close. It will take longer now because the network is much bigger. It will have to think more. But guess what? It worked now. Now that I made it more complex, it was able to understand that the relationship wasn't merely if this is true or if this one is true. It understands now it has to be when they differ. So I had to draw many associations, many connections, and then it would use all of those associations connected to one neuron in the third layer in order to understand how it really works. This is what they call a non-linear relation. In this case, here. This guy over here is very important because this guy is the one that associates these two. Well, I think this is pretty much it. I still have 2 seconds. Does anybody have questions?
Do you consider implementing other type of connection, like for example, convolution neural network? Have you looked into that?
Yes, exactly. At first, this thing here, it only does a feed-forward network, which is the simplest one. It's the first one you learn. Yeah, so far it only does this one because it is the only one I know how to do so far. But as soon as I learn how to do the others, it will do all the others too.
Cool. We have an online question from NX Leet. Is there a practical reason to create a color recognizer with neural networks instead of just converting it to some other color space and writing a bunch of if statements?
So the reason was simple. It's because I wanted to start my own project so I could learn how to do it myself. It was something that I did for educational purposes. But if you're wondering about a practical reason, because there are so many different colors, I would have to write so many if statements that I figured it would be easier to make a network that figures it out instead of me having to sit there for 20 hours straight typing approximately 600 if statements.
In the GUI you have, maybe I missed it, but can you configure the activation function you have at each like node in the graph?
Oh, no. So far, it only uses the sigmoid function as the activation, and you cannot change it yet. So far, it is very rigid so far. Later, I will add more features so you can set up a different cost function, a different backpropagation algorithm, and so you can also try different architectures as he had pointed out. But so far, it only uses the sigmoid function as the activation function.
At the beginning, you mentioned that the AI stuff isn't actually intelligent because it's just following weights and summing them up and deciding yes, no. It's completely deterministic. I think that kind of reframes or frames the question the wrong way, because I look at it as, are we intelligent, or are we just simply a sum of probabilities and weights and have a deterministic thing? Because once I learned how these neural networks worked, I found a lot of similarity with the way my own head works. Okay, and I can't escape the idea that maybe we are just neural networks with a sum of weights and come out with a deterministic thing, and we're not actually intelligent at all.
Yes, I totally understand that. I once met a guy who said, stating a computer cannot be intelligent because it is only able to execute a set list of CPU instructions is the same as stating that the human brain is not intelligent because it is only able to execute a set list of physical and chemical phenomena. But what I mean is, our brains, they have so many different neurotransmitters, and they have so much complexity. And when you look at the neural network, it's something so crude and simple that it makes you feel a little disappointed, because when you hear the word the neural network, you imagine something so complex, and when you look at it, say, is that it? That's what you call a neural network?
Maybe that is it. That's what we are.
All right, we'll have to cut the question short there, but thank you.